more colorful finish. How else might one achieve a permanent finish with color and texture? Well, another conventional method is stone cladding. Often, however, the cement mortar holding the tile to the wall does not get adequate water while curing, resulting in a weak bond and the tile falling off. Falling tiles may be an ingenious way to check population growth, but they are hardly likely to endear a building to its users, and the steep cost of scaffolding for tile replacement on a multi-storied structure can bring on builders' vertigo. A building is an investment in the future. For the average man, the statement of a lifetime. Few needs can be more pressing, more deserving of our attention than the need for a shelter that will last and can be passed on to the future generations. In this context, the widespread demand for a variety of attractive, resilient, and maintenance-free building materials is entirely understandable. So is the universal aspiration for a permanent finish. If you are looking for an architectural illustration of ingenious material use, take a look at history. Among the best examples are the dowel constructions, with stone integrated onto random masonry. The interior masonry has only as much strength as is proportionate to its need, while the stone surface provides a resilient and permanent exterior. While achieving considerable material economies, the combination makes for an integrated walling that has stood up wonderfully to the test of time. How can one translate this excellent example into a contemporary solution? Well, the aspirations for permanence has three aspects, and these are in fact the criteria for a walling material. The first is rationalized load-bearing strength. The second is a permanent finish, a surface that resists erosion, seepage, and the vagaries of the elements. Add to these the requirement of beauty and variety, and you've got the ideal walling material in a nutshell. With these criteria in mind, let's turn to a contemporary technology that answers all three requirements comprehensively, and yet with great economy: the ramlochan tile. The basic mold is a simple wooden box with holes and a pair of wedge-shaped inserts. A polythene strip is placed to prevent adhesion, and this also prevents the slurry from leaking out of the holes. The mold is wet along with the wedges, which are then placed in the mold with their broader edges facing upwards. Another layer of polythene film is laid over the wedges. The mix is then poured in and filled to the top. It has equal proportions of cement and fine aggregate, the latter of a 6 mm size, giving the thickness of the tile. Here's what it looks like in section. The upper surface is firmly tamped and smoothened out. Lime or mortar is used to finish the top, and an initial setting time of 15 minutes to half an hour is allowed. The surface is gently washed with a brush and plain water, and the newly made tile is pressed out with the help of the holes on a flat, red mud plastic sheet. It can be lifted and stacked the same evening, or if it's winter, the next day. Just 3 or 4 days of curing with water sprinkled twice a day, and the batch is ready. An average team of 2 masons and 5 helpers can make 150 to 200 blocks a day, inclusive of tiles. A simple timber mold is again adequate for integrating the tile with the block. Plain mild steel bar clamps are used to hold the sides of the block in place. A coat of cement slurry is applied to the back of the tile for bonding, and the tile is placed in the block. Now the mold is filled with either mud or lean concrete of a 1:3:6 mix to form the block. The mix is compacted with an ordinary wooden hand ram. 40% boulder infill may be used, further reducing cement consumption. The mold is topped up with the same basic lean concrete. And finished smooth with a trowel. The steel clamps are removed. The block is demolded simply by removing the sides. Water curing saves the extra effort of burning, which conventional bricks require. The tile can be integrated with the block within 2 days of its manufacture, and the block can be laid within the next 2 days. Permanent finishes are a must, but the rational approach would be to integrate the finish with the building block at the time of manufacture. If a block is manufactured with a non-erodible finish and with a lean backup material of a rational crushing strength, it turns out to be more cost and energy effective than a brick, which would further entail plastering on at least one face. Unlike the brick, whose parameters are fixed without regard to specific needs, the ramlochan tile block can be manufactured on-site using cheap and simple hand molds and saving on transportation. As the tile provides a non-erodible finish to the block, even mud can be used as the backup material with just 2% cement to stabilize it. A variety of textures are possible with different types of stone aggregates and by using metal oxides of copper, iron and the like as pigments. Cost-effective methods, like the use of lime with grey cement, can give you the same effect as a white cement tile would. Although this takes more time to set, it's a substantial saving. A good handheld vibrator can achieve even greater economies, reducing cement use by a further 30%. Needless to say, the permanent finish eliminates plastering entirely.
We tend to take bricks for granted as a ready-made product, forgetting there is an entire process of manufacture